Okay, it's review time here. We're going to review the midpoint formula and distance formulas just for a couple things here to get back in the swing of things for the fourth quarter. Recall that the midpoint formula. Now I set it up just a tad different than what you see in a lot of textbooks. I do the midpoint for the x values. So I go m sub x value plus x value of your coordinates divided by 2. Then I go m sub y value plus y value of your 2 points divided by 2. Why in the world do I do that? Why don't I go just like, excuse me, why don't I just do this like you see in the books? And the reason behind that is this. Yes, I'm going to take those answers and put them here anyway. If I were asked to find a midpoint, then I could use a value and plug in here. I can set up my each individual problem to solve for the missing points instead of just always assuming I'm going to find a midpoint, which is what this is doing. So let's look what we got here. We're going to start with this problem. Find the coordinates of M. It is the midpoint, not an endpoint. So I could use this one. If I've got to find an endpoint, I'm going to do something like that. So, and it's a segment JK. So let's look and see what we got. Doesn't matter which one we call X1, Y1, X2, Y2. Absolutely not. So I set mine up. So the value for the midpoint X is going to be, I'll go X1, Y1, X2, Y2. So I'm going to get a negative 1 plus 6 divided by 2. M sub y is going to give me 2 plus 1 divided by 2. As everybody knows, I'm going to get 5 halves right here. I'm going to get 3 halves right here. Leave them as an improper. Change them to a mixed number if you want. 5 halves. 3 halves is what our answer is. They're just finding the midpoint. Okay, so now we look at our second example. Let's see if that focuses a little bit. That's better. On our second example, we've got segment AB. We got to find an endpoint of this segment if A is here and M, which is our midpoint, is located here. So we're trying to find point B, an endpoint. So how do we set this up? Well, I know these. I'm going to call this X1 and Y1 because they're points of an endpoint. These are points not of an endpoint, so I don't want to plug them into the formula the wrong way. These are from the midpoint. So I'm going to call this M sub X, the X value for it, M sub Y, the Y value. So this is where setting up like this, or at least knowing how to set up like this, comes in as my advantage. So M sub X, 1/2, equals X value. Don't know for point B, so you could call that X sub 2, Y sub 2 if you wanted. So plus X divided by 2. Y values, 10 equals 12 plus Y divided by 2. So what are you going to do? Solve. Multiply both sides by 2. 1 equals 5 plus X. We're going to subtract our 5. X equals negative 4. Multiply by 2. 20 equals 12 plus Y. Y is equal to 8. So the endpoint B is located at negative 4, positive 8. All right, switching gears to the distance formula. Let's make sure we recall that in the coordinate plane, the distance formula excuse me. Don't forget, some of these problems are going to ask for exact answers, so simplest radical form at times. Not all the time, but there will be times, so don't forget how to do that. So our distance formula. All right, let's look what we got here. Frisbee golf, as I call it, or some people call it disc golf. All right, Troy threw his disc, and it's 20 feet short and 8 feet to the right of the basket. On his first putt, the disc lands 2 feet to the left and 3 feet beyond the basket. If the disc went a straight line, how far did it go? All right, a couple things you might want to do here. I would suggest drawing a little grid and see what we have. The origin will be where we're trying to go. Everything based off of that. Got your little drone up there. You can see everything that's going on. So he was 20 feet short and 8 feet to the right. Well, you can see right and left. That's going to be your x-axis. 20 feet short and 8 feet to the right. So that means I'm going to be 8 here and 20 here. If you can do this without a visualization, awesome. Go for it. Then he threw it a second time. And this one is 2 feet to the left and 3 feet beyond the basket. So here's your basket, 2 feet left, 3 feet beyond. So we're at these 2 points. The question is, if it was thrown in a straight line, how far did it go? Okay, distance formula, here we go. Does it matter who I call x1 and y1, x2, y2? Absolutely not. So I just went ahead and labeled them simply because that's the first piece of information I got. There's a second. You want to label them the other way, find all what matters, keep your x values together, keep your y values together. So we're going to take 8 minus a -2. Yes, I'm very literal in these things. I know some of you jump the gun on that. Fine. I also know some of you sometimes get a simple mistake once in a while. Just be careful. And then we're going to add to it the difference in the y values. So I got a -20. And I got a 3 up here, so -3, the quantity squared. So as we work through this, you got me going with my add opposites. Add opposites. So when I see here, I got the big old square root. I've got a 10. I'm going to square it. I got a -23. I'm going to square it. Gives us 100 plus 529. So as we do this, we are going to get the square root of 629. Now, let's not go crazy. Let's look at the problem and use our logic. I really don't want to sit down and say, oh, how far did that go? It went the square root of 629. It will break down some simplest radical form. You want to know how far it went. So we're going to take the square root of it and probably round it to the nearest foot. And as we take the square root of 629, you're going to get about 25 and some change. So let's go to the nearest foot. So it traveled 25 feet using our distance formula.